Let us use MySQL to create, read, update, and delete. We'll see examples of creating table, reading from the table, updating table, and deleting table. We are going to use both MySQL command line client and JavaScript client to demonstrate this. To get all the JavaScript files, go to this URL, hackyourfuture/databases/master week 1, and there are JavaScript files that contain our JavaScript client. For MySQL client, on your Linux and Mac, open the terminal and type the MySQL command with the user, hyf user that you have created earlier. If you have not, then create a new user and get this prompt. MySQL client prompt looks like this. Once you have that prompt, you can open create table.js or insert value.js, these files in either Visual Studio Code or in the terminal. I'm going to open these files in the terminal. I'm in the week 1 folder and there's a create table.js. Now we'll look at the commands one by one. First command is the create table. We're going to create table employees in the company database with these 5 columns. Let's switch to the database. So if you do show databases, you will see all these database. I'm gonna do use company, which will use the database company. If I do select database, I know that I'm in the database company. If I do show space tables, I see a lot of tables because I created these tables for some previous classes. Now I'm going to delete them so that we can create the tables from the scratch. So I'm just going to say drop table employees. I'm going to drop the database so that I can show you the creation from the beginning. So show databases, use user DB database, and then I'm just going to say drop database company. Now this particular command is very dangerous, drop database company, because it will delete the table along with all the data in it, but that's fine. We'll recreate everything. I'm going to do create database company. You have done it already, and I'm going to do use company. I create the database company. Now we'll do show tables. There are no tables. Now let's create the table employees. So create table employees. This is the syntax. I write create and table in the capital because it's part of the syntax, and I write plural of employees because I prefer plurals when writing table names. It's up to you if you want to say employee or employees. Now I'm going to use these 5 columns: employee ID, which is integer, employee name, which is text, varchar, so be it. Then I'm going to use salary, which is float, because you can get like, I don't know, 2000 euros and 10 cents. Joining date, date time, spelling should be correct, okay. And gender, which is an enum, can be M or F. Now we live in Amsterdam, so there can be more genders, but for the sake of this course, we are going to stick to M and F. This is how you create a table. Now the table is created. How do I know? Because it says query OK. I can do the same thing with with a JavaScript client. So the create table JS, I need a MySQL JS, which is a package I require. Then I create a connection object. The host is equal to localhost because this is my MySQL server is running on the local machine. HYF user is name of my user, HYF password is the password of this user, and the database name is company. Connection.connect will connect to the database. Now instead of creating table for employees again, I'm going to create table for, let's say, department. I just want to see if there is a department table created later on. Okay, this is a part of the exercise, so I'm not going to create the table department. Okay, there is no project, so I'm going to create table project with the JavaScript client. Create table project. I'm going to say project ID is integer, project name varchar. Project cannot have date of birth, but it can have a start date, which is a date. Then a project can have a project manager. Project will not have a gender. So let's create a manager. The type start date and manager, which is varchar 50. We say connection.query. This particular line will actually send the query to the database server. It will cache the errors in the error variable, and otherwise it will give you the response, and then we will end the connection. Now let's see how this works. So I save the file. You can have the same changes in your VS Code and then go to the VS Code terminal and then type node space filename.js. When you type it, you are going to get something like this. If you get this, it's a happy response. The reply is undefined. Even though it looks bad, undefined is good because of JavaScript, which means there was no error. And now how do I verify it? I check which database I am currently in. I'm in the company database. Now I do show space tables, and I see two tables, employees and projects. I can verify if the columns that I created with the JavaScript client are the same columns that I see in the database. Describe projects. I can describe table. Oh, my spelling is wrong. Okay, describe projects. There we go. Project ID, project name, project start date, and manager. So exactly the columns I created with the JavaScript client. The point is, whether you use a JavaScript client or you use MySQL command line client to create table, you can create a table. Let's move on. So we saw how to create a table. Now let's insert some values. This is the syntax. Insert into, and then the name of the table, employees, then values, and then all these values. Insert into employees, values, and I'm just going to use the same values here. So I'll say 101, name of employee is Dan, salary is 5,000, some date of starting, and Dan is a male name, so M. Just like in the bash, with up arrow key, you can get to the previous command and just make a few changes. Just because I'm so lazy, I'm just make Dana, which is another employee. Let's give her more salary. start date maybe previous year and female. There we go. So now we see how to insert values. Now there is another syntax for inserting values which is much longer than the previous one. So in this syntax you say insert into employees, the same. You don't write the word values here, you write all the column names, but you may choose a different order than the order in which the table was created. So if I describe employees table, the values must be inserted in this order: first employee ID, then name, then salary, then joining date, and then gender. If I don't follow this order, it will fail. Just as an example, if I say 103 6000 comma name Tom, I get error, data truncated for column salary at row 1, because salary is supposed to be float and double quote Tom is a string. This cannot be salary. So I cannot insert value like that. I have to have the same sequence. But you can change it by doing this. Insert into employees, and then you say what is the sequence of fields you will follow. I will first give employee ID, then I will give salary, then I will give employee name, then I'll probably give gender, and then the last I will give joining date. And then you type values, and then you give values in this sequence: 103 6000, then name is Tom, then gender M, and then joining date 2019 0101, for example. I have some syntax error. I'm going to check what is the problem. Insert into employees. Then I have employee ID, salary, employee name. All are correctly spelled. And then values. Looks correct to me. Let's see what is in the table. With this command, select star from employees, which I will describe in detail later. Okay, but the value for employee ID 103 is not inserted correctly. So I will try now again. Employee underscore ID, salary, employee underscore name, gender, joining date. I have comma between everything. I have comma between every value. Looks exact. Oh, my bad. The spelling of inert is wrong. It should be insert. There we go. Let's look at another syntax. First, let's verify if this is correct. Select star from employees. Yeah, there we go. The value of Tom is there. One more syntax, you can add multiple values at a time by just having more values. So like this. Here I will just say 104, say salary 7000, and name Tommy instead of Tom, and M same date, and again comma 105 comma name Eva, salary 3000, No, I need to have salary first because that's a sequence, then the name, then the gender, and then the joining date. Now see, you see query OK and records equal to 2. So you can insert multiple records at a time like this. Now all this syntax had insert into the name of the table, then the sequence of the columns in which you will give the values, and then values. You can also use the set syntax, which does not use the keyword values. Then you have to give name of the column equal to value, name of the column equal to value, name of the column equal to value. So something like this, insert into employees, and then you do set employee name equal to, who is not here yet, let's say Yarun, comma, employee ID equal to 106, salary equal to 4000, gender equal to M, comma, joining date equal to 2018 May 4. There you go. Now you have seen 4 syntaxes of inserting a value into database. First is insert into name of the table, values, and then all the values in the sequence of columns in which the table was created. Syntax number 2, insert into name of the table, then sequence of the fields in whichever order you want, and then values, and then values in that order. Syntax number 3, to add multiple rows at a time. So insert into employees, then sequence of the columns, and then values multiple times. You can use this syntax also for first variation. So you can do insert into employees values, all these values. Instead of semicolon, you can use just comma and use another sequence. Remember that semicolon is the delimiter. So when you have semicolon in the command ends. But comma means you have something more to go. If you want to add multiple rows at a time and you don't want to mention the sequence yourself, instead use the sequence in which the table was created. It means ID, name, salary, joining date, and gender. You can still use this syntax for the variation number 1. Let's see a quick example of that. Insert into employees values. Now you just have to follow the sequence, which is employee ID. Let's say 108, name Ali, then salary 4800, then gender M, and joining date 2019 0101, doesn't matter, and comma values 109, comma Fatima, comma 3800, salary F, gender, and his date 0101. Syntax error, it's probably this one. Yeah, I don't have to use values multiple times, just multiple times parenthesis. Incorrect date time value M. Oh, again, I use different quotation marks, which is bad, and my salary value should not have quotes. See, MySQL catches all your errors. Again, joining date. Oh, I think joining date comes first and then gender. That's why. I have to follow the sequence. There we go. After I follow the correct sequence of employee ID, name, salary, joining date and gender, comma, another employee's ID, name, salary, joining date and gender, then I can see the values in the table inserted correctly. See, now we have seen 4 types of syntax. Fourth syntax was of course insert and then set column name equal to value, column name equal to value, and so on. The simple tip, if you don't remember the column names, you know how to use describe command. So just do describe and employees. See the columns and the types of columns. Now we have seen this command already, but let me formally explain what that command actually means. Select is a keyword which will select something from the table. Star means all the columns. From is the keyword, it's part of the syntax, and employees is name of the table. Now let's see select employee name from employees. This command will only give you employee names. Now select employee name, comma, salary will give you employee name and salary. If you want to see all the columns, then you do select star from employees. So star means all the columns. It's easy to see how you filter the columns. You just write name of the column after select. But how do you filter the rows? You may want to have employees just with salary greater than 3000. Then you use the where clause. Something like this. Select star from employees where salary is greater than 3000. Since all the employees have salary greater than 3000, you can also change it and make it, let's say, 5000. Then you see only 3 employees. Dana, Tom and Tommy, they have salary greater than 5000. You can add multiple conditions here. You can also say give me all employees with salary greater than 5000 and gender equal to F. And then you see only Dana. She is the only employee that earns more than 5000 and is a female employee. Let's see a quick example of update command. Now remember that update command updates the values as opposed to the alter command. Now update command works on employees like this. So update employee, you don't have to write table. Set, let's say salary equal to 7000. Let's give someone a promotion. Let's give Fatima a promotion. It's a big promotion. Set salary equal to 7000, and then now we have to say the condition, because if I press semicolon now and enter, then it will update salary of all employees. I don't want that. I want to have a condition where I can say employee underscore ID equal to 109. So find employee whose ID is 109 and updates that employee's salary to be 7000. Says rows matched equal to 1, which means there is a row in which employee ID is 109 and it is changed. If you want to see it, of course we can do select star from employees and you see the changed value of Fatima. If you do something like this, the query is still successful, but you will say, oh, there is no employee ID 119. Yeah, and you will see that in the error message, or in this case information message, that rows matched equal to 0. So there was no match in this table for employee ID 119. But if there was, it would be able to update. So that's why the query is okay. There is no error in this query, because if there was an employee with ID 119, it would be able to set the salary to 7000. But if there was no such employee, so there was no rows, matched. Now let's delete some rows. This particular command deletes all the rows from employees who joined after 1st of July. Let's do that. Delete from employees where joining date is we have some 2018-19, so yeah, let's do that. Joining date is greater than 2018. No, then we'll delete all of them. So no, 2019 February 1st. 2 rows affected. So who are deleted? Those who started after 2019 February, which is, I think, Dan should be gone and Ava should be gone. So let's start from employees. Correct. These two people are gone because they joined after that particular date. Next is the exercise. How would you write an SQL query to find all employees who are males? I'll give you 10 seconds to think about it, or maybe write the query yourself. And if you can do it, then type the query. I'll wait. I'm checking some cool music to play while you're doing this. Okay, enough. Let's write this query. So select star from employees where gender equal to M. I think most of you would get it. Find all the employees who are males. Just checking the gender column to be equal to M. Next, write an SQL query to insert 4 more records in the table of employees. You know how to insert values into the table, but now you want to write only one query, not multiple queries. So exactly one command, exactly one query to insert 4 more records, not one record but 4 more records. And I'll give you 1 minute maybe to think about it or to write the query and make a different music. Okay, let's write this query. Insert into employees values 111, name, then some salary, doesn't matter what salary you write, some joining date, and gender. I will not say semicolon here because I want to write one more value 112, Anna 1000, if one more value 113, Christy salary 6000, joining date 2018, M 114, Nor salary 7000, 2018, 0101, and gender F. I have 4 records now. I can type semicolon, and there are 4 records inserted now. If I do select star from employees, I will see 4 new records. Next query, next exercise, write an SQL query to update the salary of all female employees to 12,000. All the girls will like this query, and I will give you a minute to write this query and find the next music to engage you. It's almost 1 minute, so let's write this query. Update employees, set salary equal to 12,000, where gender equal to F. We'll update a salary of all employees with gender F. 4 rows match, which means we have 4 female employees. Let's see their salary is updated correctly. Yes, Dana has salary 12,000, Fatima salary 12,000, Anna salary 12,000, and Noor salary 12,000. Good. Next exercise, write an SQL query to delete all the employees whose name starts with B. Now let's see if we have any employees like that. Otherwise we have to change the query. We don't have anything with B. Let's do it with A for the sake of this exercise. Write SQL query to delete all the employees whose name starts with A. So sorry for Ali and Anna. We have to delete them. where is my music? Let's slide this query. Delete from employees, where employee name like is the keyword you have to use. If you Google it, you will know. And what's the query? Start like B. Let's say a%. A percent is a wildcard character which will match with everything. So a% means anything starting with A. Let's see if it actually deleted. It says query OK, so should be deleted. So there is no Ali and there is no Anna. Tada! Last exercise, write an SQL query to create a table called departments with following columns: department ID, department name, and manager. I will give you half a minute now because it's easy. You know how to create a table. Okay, maybe I'm impatient, but I think half a minute passed already. Now let's create table. Departments. Columns are DPTID. You also need to come up with the correct data type. You can either use text or varchar, doesn't matter. Int and manager. There you go, created table. So essence of all these commands is it's very simple: create, read, update, delete. They provide you a structured way to interact with database tables. Now, there are some miscellaneous concepts here I want to cover, and first is aliases. Alias is nothing but a nickname that you give to a column when displaying the column. Now, aliases are particularly useful for nested queries when tables have long names and joins are used. But for now, we will only concentrate on example without a nested query. Nested queries will be covered later. So select employee no, comma employee name from employees. If this is my query, okay, employee ID and employee name. This is what I see. Instead of seeing employee ID, employee underscore ID, employee underscore name, I can also see something like this. I don't want to see employee underscore ID as the name of my column. I want to see identifier, and I want to see name instead of employee underscore name. It is only for the output and the display. It does not change the name of the column itself. So if you describe employees, the name of the column is still the same. Aliases are only used when displaying them on the console. You use it with as. And you have used this when you type your very first connection test. So in the connection test, this was the query: select 1 plus 1 as solution. In this, solution is name of the new column. That's why if you type that query, select 1 plus 1 as solution, you will get name of the column as solution, and then the only value in this column is evaluated here, 1 plus 1. You don't need a table here because this is treated as mathematical expression and it will be evaluated. The next miscellaneous concept is not null and default values for columns. So if you describe, for example, employees again, you will see a lot of these columns. So first two columns are easy to explain. This field is another name for column or attribute. It's just a column name. Type is the data type for that column, and there is null and default. Some values can be null and some values can have default, which means, let's say we can have salary cannot be null, right? Every employee wants some salary, so we cannot have salary as null, which looks very wrong. For gender, we could say null, and that could mean that the person does not want to reveal the gender. That is something that should be possible. Similarly, for salary, we can have a default as the minimum wage that is allowed by the government, that every employee must get at least that much salary, and then some more if the employee performs better. The columns can have null and default values. Now I'm going to create a table with the demonstration. So I'm going to copy this basically. So create table. I will name the same default not null demo. This is the name of my table. First I will have a number which is integer without any specification. Then I will have num2 which is int not null, which means this cannot be null. Then I will have num3 which is integer with default value 5555, and then I have num4 which is int not null. Let's do it on the next line. Num4 int not null default. Now I want to see if I can select this one. So default is 1111. Okay. There we go. I created this table. Now if I describe this table, describe default not null demo, this is what I will get. Now look, when I create a table employee ID with just int, I get this type. I'm going to explain int 11 in a minute, but only concentrate on null and default column now. By default, null is always yes and default is always null, but here we see that only for num1, because num1 was created with data type int, so the default null is yes and default is null. Num2, we say explicitly it cannot be null, so we must provide value, but the default value is null. num3 can be null, but num3 has the default value 5555, and num4 cannot be null and has the default value. Okay, now let's try to insert in this particular table. And now we are going to use these examples over here. So first we are trying to insert into the table and set only num2 and num4. So insert into default not null demo, and set, we are going to use set so that we can set particular column's value. So set num2 equal to 1 and num4 equal to default. Try to guess what would be the output. Because num1 is allowed to be null, so num1 should be null. Num3 is allowed null, so num3 should be null as well, right? So what would be num2's value and num4's value? Let's see. We'll select star from default not null demo. We see num1 is equal to null, num3 is not null, but we expected it. Why? Because num3 has the default value. So if we do not provide num3's value, then it will be default value 5555. Num4, we explicitly say that num4 should have default value, so it will have 1111, and num2 cannot be null and there is no default value, so it will take the value we provided. Again, let's try to insert with these values now. So insert num2 equal to 1 and num3 equal to 233 and num4 equal to default. And now let's see what is the content. Now because we provided the value for num3, it will take the value we provided and it will not give the default value. So that's how default and not null work for the columns. Now what is this int n thing? When I created integer num1, num2, num3, num4, all were integers. Employee ID was also integer. I didn't say anything about 11. What is this 11? This 11 is not about how many digits you can have. It's about how many spaces you use to represent that number. How many decimal spaces. So I'm gonna create this table now to demonstrate. So create table test int with num1 int 4 0 fill, num1 int 4 0 fill. You will see what it is. Num2 int 6. So it looks like num1 is a 4-digit number and num2 is a 6-digit number, but that is not the case. I'm going to insert into these values 23, 34. Allowed. Oh, I need to have values here. Values. It is case insensitive, but I just try to type capital letters for keywords. You can have values in smaller case as well if you like. Doesn't matter. 3 and 534. I'm gonna just type the same values as here. Then 14563 and 534. Then 12345, that's an easy value, and 98534, 98534. Now here you can already see if num1 was only 4-digit number, this value should not be allowed, but 12345 is perfectly inserted. Also 14563 is perfectly inserted. So int 4 has nothing to do with 4-digit number. That is already clear. Similarly, here we can add 1 2 3 4 5 6 7. Now let's see what is actually in this table. Test int. What do you see? Aha, there is slight difference over here. So because num1 was created with int for 0 fill, when displaying that number, if the number is not 4-digit number, the digits will be filled with zeros. So 3 is printed as 0003 and 23 is displayed as 0023. If there are numbers with more than 4 digits, those digits are not 0 filled because num1 was declared as int 4. Clear? And num2 is not declared with 0 fill, it is declared with int 6, but there is no 0 filling going on because we did not mention that option. This int n only makes sense to use when you are going to use 0 fill as the option. I think this is the last miscellaneous thing. Yeah, the last miscellaneous thing is about date time versus timestamp. Again, I'm going to use a demonstration table for this. Date time and timestamp are two different data types. There are situations when you have to use one over the other. So create table test timestamp. I'm going to have just dt, which is my date time, and ts, which is my timestamp. Table with only 2 columns. Now I'm going to insert some values into it. Insert into values. No, insert into test timestamp and values. I will just say 2021 one. So 2020, the first day of the year, colon, no space, 00. That's exactly when the new year started. 2020 0101 space 00 colon 00 colon 00. The same. Yep. I will select star from test timestamp. I get the same timestamp, then you will see what's the difference between the two. Remember from the data types discussion, timestamp also stores the date time along with the time zone information. Now if I change the time zone of my database server, which is possible to set time zone command, equal to +05 colon 30. Is that the syntax? Yes. The time zone in India basically. And then if I select star from date timestamp, there you see the difference. The value in the column of timestamp will automatically change to the current time zone. And it is very useful for the fields like last login in the database, where you want to track users from all over the world when they are doing any activities. So be cautious when you use date time and when you use timestamp. If the time zone changes, the value in the timestamp column changes according to the time zone. And that is all I have for this session.